All right. So, Mohammed, the floor is yours. The subject is really interesting. So, let's learn some incredible stuff about underwater photogrammetry.
Thank you very much, Nestor. So this presentation will be focusing more about the ancient lighthouse, one of ancient seven wonder of ancient world, which now it's underwater in Alexandria in Egypt. So I will show to you the tips and tricks how we capture the whole site, the entire site, since we started the project in 2012 till 2025 right now, and also how we capture underwater objects from upside down. So, but first of all, let me give you very brief introduction about the ancient lighthouse, which I believe everyone know what is it. So, it built, of course, it took 15 years to be built, and it's built in the Ptolemy era, specifically in Ptolemy II, in an island called Pharos. Unfortunately, through time, there were many earthquakes hit the city of Alexandria. The major one was in the 14th century, which was in the Islamic time, which collapsing the whole lighthouse. However, Sultan Qaitbay in the Islamic time, he decided on the ruin of the ancient lighthouse after it sank under the water to build his castle to defend the port of Alexandria. As you can see from this image, this is an aerial image show you the castle of Qaitbay. But we are so lucky because he didn't build the castle on the ruins, but actually the ruins, just 1 second, the ruins in front of the castle, and it's distributed on around 15,000 square meter. So how we discovered the site? Uh, the site discovered by a hobby diver. His name is Kamal Abu Saadat. It was in 1968. He was diving, and he also a fisherman. He was like, he don't have any diving equipment, but he was diving in the eastern harbor of Alexandria. And while he was diving, he was seeing ruins and colossal statues underwater. One of the things is a colossal statue of Isis. Then he reported the Ministry of Antiquities, which wasn't a ministry, it was like a kind of department at this time. And he informs them about what he finds. Then the ministry just there were another English woman. Her name is Frost. She came with Kamal Abu Saadat, and after they did the diving and investigations, they confirmed these ruins belong for ancient lighthouse. The navy of the Egyptian navy actually left the statues in the 1962 after Kamal Abu Saadat report about the statue. This is where exactly the site distributed in front of the castle of Skype, and it's distributed around 15,000 square meter. However, in the 1994, Professor, my master supervisor, and now he is my PhD supervisor, Professor Jean-Yves Amprier. He's a French archaeologist and the founder of Centre d'études Alexandrie. This is an institution in Alexandria related to any Alexandria studies, especially archaeology and heritage. So in the 1995, after he founded the institution, he and his team make a GIS map for the site, and they recorded in the first 10 years around 3,500 blocks underwater. Not all of them are belong to the lighthouse, but most of them are belong to the lighthouse. However, in the 1995, I guess, or 96, there were a big mission. Actually, they start to lift some of the colossal statues, Sphinx, Plisk from underwater. And I guess I was 4 years, but I still remember in the TV how this show, because everyone was watching the TV at this time. Now in the Roman theater in Alexandria, there were an underwater open museum. They put all the discoveries lifted from underwater, as you can see here. So as you can see, we discovered Barbarians, columns, obelisk, Sphinx statues, colossal statue of Ptolemy's II, and Isis statue, which most likely it's not Isis, but maybe she is Arsinoe. We still, the wife of Ptolemy's II, we still do these studies. However, in 2012, the director of the underwater site, her name is Isabel Harry, decided to do an underwater photogrammetry to record the whole ruins of the lighthouse, which was big challenge. And in 2012, underwater photogrammetry wasn't that much common, and it was very early to use photogrammetry in the field of archaeology. And I was actually in 2012, I was just fresh graduated from the university, but I was so lucky because I had experience in the field. So I had a meeting with Johnny Van Breer and I showed them some of my work. Then they hired me to work with the team. As you can see, it was very challenging in 2012 and 2013 because we spent the whole year to build our methodology, how we're going to do that, especially the visibility underwater wasn't in a good condition. When we do diving, underwater diving, we actually not dive the whole year. We choose only between like a few weeks or 1 month, 2 months in the whole year, because to take a permission from the Ministry of Egyptian Antiquities, it's a big challenge. And also we have to choose the right time to dive to get the maximum visibility. So at the beginning, we just like underwater, we put a grid where exactly we will do photogrammetry, for example, for a specific area. We use a very manual tools and we hold the camera and start to capturing image. We capture image underwater in different distance because, as I mentioned, unfortunately the site, especially the site, is very challengeable because it's located besides the well of the entire town. So sometimes in some specific times in a year, we got a good visibility up to 3 meters, but most of the year, unfortunately, we got up to half-meter visibility. So how we capture underwater site? So the site actually underwater between 2 and 9 meters, so it's not that much deep, but still very challengeable because the visibility is very difficult. How we capture the site, it's exactly simulates the drone capturing. You are underwater, you are flying. You just start to choose what kind of camera you will choose. You will pick and you have the housing and the camera lens and choose the right condition. As you can see here, the diver, his name is Muhammad Said. Muhammad Said, he is actually the one who is responsible of the data acquisition of the whole site. So as you can see, he is so much close to the object. The site is 15,000 square meters, and this was very, very big challenge to do every year, just to dive 2 weeks in a year. However, I was the one, I'm still also the one who responsible in the 3D data processing, and we got some challenge because, as I mentioned before, the visibility is not in a good shape. So every dive I got around between 2,000 and 4,000 images for each dive. So we end up with a huge amount of images with different colors. Sometimes the photogrammetry software find it so much difficult to detect the feature point because photogrammetry is not understand what I provide the software, just read pixel, and that's why I'm just do post-processing, which is very important. We capture image with a professional camera and we do it in a raw format, of course, then use Adobe Lightroom to try to remove the filters. We are so lucky because the depth is between 2 and 9 meters, so it was very easy to remove the filter. But if we go to maximum, like between over 15 meters underwater or maybe more, we will never be able to remove the filters, unfortunately. So, but anyway, the good news that the whole color of the image will be the same, so it will not be a problem with the software. Ours, it was very problem. So anyway, for each dive, I'm just do the post-processing to try to get the homogeneous colors. So I did some tests here for 1,000 square meter. This is actually, as you can see, if you can see my mouse, this is part of the door lintel of the lighthouse. This is 5 meter tall lens, sorry, 5 meter lens. In reality, if I dive underwater, I will be barely see 25% of this part of the column, part of the door lintel, sorry. So photogrammetry was extremely helpful for us to have this kind of documentation. So anyways, the image in your right is before post-processing, and as you can see, we can see the underwater different filters, greenish, dark greenish, and bluish, and these kind of colors. And the one in your left after I do the post-processing and remove all the colors in the Lightroom. I didn't mention that before, but the main goal at this time to do a whole ortho-recified image to the whole site. So this was the main goal for the Centre d'Alexandrie, why we do photogrammetry, and to remap the whole site, and to also to georeference the 3D model and the ortho-recified image and digital elevation model. So this was the main objective for the mission. So, however, this is the actual mission started in 2014 after we build our methodology and know what we are going to do and all of this stuff. This area we capture around 17,000 square meter, 17,000 image, sorry, to cover only 3,000 square meter here. As you can see, we didn't capture the whole area at once because the visibility was very awful and we have to prepare for many things like put the grid. So for each dive we capture like a small area and keep the second day capture the second area and so on and so on. For each area we capture, we take an overlapping from the previous one and so on. So this is in 2014, this was in 2015, this was area capture in 2016, and so on and so on and so on. The main challenge is how we are going to merge all of these areas together. To use inside the software, the photogrammetry software, to do it manually by putting marker. For our field as archaeologists, this wasn't 100% accurate because the overlapping between each mission and another was around between 20%. So maybe it will line up in the edges, but maybe in the z-axis behind will not be that much accurate. So what we are going to do, first of all, we have here the site, as you can see. For each mission, we take an overlap. So this was in 2014, for example, and this in 2015. And this is the area of overlapping we capture in both sites, and so on and so on and so on. So why we took overlapping area for each season, for each year? Well, I will answer these questions after this slide, but anyway, some of the time, because again, because the visibility wasn't so much good for us, when the photographer take images, sometimes the visibility, for example, in this area, which was the most important area, which have some statues bases, should be in front of the gate of the lighthouse. The geometry itself, the 3D model looks like melting on the sides. These blocks or these statue bases is enormous, it's a huge. So each dive, because we are limited with time, as I mentioned, we are only restricted with few weeks in the whole year, so we have to do it right. When the diver captured, for example, 2,000 image, I took the image and do the processing in the same day, just in a low quality processing, align image, just I need the alignment to check everything. So for this area, for this example, we got a very bad geometry on the sides of these blocks. So I tell the diver at night or the second day in the morning to capture this area. So I just build a very basic also image for this area and tell him, okay, I need to capture more image in this area, and this is what he's doing. So before he start to continue working, he capture 360-degree images for this area. So it's like combined between oblique images and 360-degree for specific areas to capture the sides, the side view, I mean. So here's the thing: why we took overlapping area for each season. First of all, we ask ourselves a major questions: how we going to merge each season individually? We find the manual tools because we start at the beginning in 2012 to do it manually, but we find actually the X and Y and Z, especially the Z level wasn't accurate when we do merge by marker or by feature point. So we eventually decide to do merging by geolocation, by put ground control point distributed for each specific area. We like, for example, in 2015, we will decide to work in a specific area on the site. Before we capture, we take the photograph of the site, we distribute between 10, 15, maybe more ground control point. As you can see here from this image, this is looks of the ground control point we captured. Then the diver starts to take the photograph, and maybe later we start to get the coordinate system for each point. So for this specific site, we didn't use the GPS. You can use the GPS, of course, but we for this project aiming to get the maximum highest accurate result as much as possible in terms of the 3D model and also for the geolocation of the site. So we use the total station. The total station was sitting uh, on the land, and we put a buoy and the mirror on the buoy. And as you can see, we put a lot of, like, we have the rope go down, and there are a net to make sure it's very straight. Then we capture the diver capture the point, and the total station, the geographic person, he just outside captured this point, and we kept doing that. To capture this point, we choose the best day ever. Just there are no much waves because the diver have to do the calculation of the depths and this kind of stuff. So we have to make sure there are no much wave and the sea is just in one level. So it was a big challenge for us. However, sorry. Oops. So anyway, so this is actually the result we achieved since we started the actual mission in 2014 till 2025, or 2024, I guess. Sorry, because I didn't do process for 2025 yet for extension area. But anyway, this is actually the castle of Kite Bay, and as you can see here, this is what we achieved till now. This is an ortho-recified image to the whole, to around more than 75, 80% to the whole site. And this was extremely helpful for us for many reasons, which I will explain in the next few slides. One of the main things is this ortho-recified image is taken from over 143,000 image. The maximum resolution is up to between 0.3 and 0.7 millimeter, the ground sampling distance for each pixel. That means that I can keep zooming in to see the grain of the sand. This is enormous ortho image. This is another view, show you the sites, the site, how it looks like. As you can see, in 2014, we have 24,000 image. In 2016, we have 4,000 and so on. In 2019, we have 32,000 image captured underwater. In 2020, we have 20,000 image and so on. This is actually how in Agisoft Metashape, we can export the camera positions for specific areas. So as you can see here, it just simulates the drone imaging that keep back and forth, just make sure there are enough overlap, because especially this is a challenge, we are very close to the subjects, not like the drone image, we are like 10 meter, 20 meter, 30 meter or 50 meter above the ground. So this is totally similar but different, As you can see, some images is a circle here in the middle because we take some 360-degree for some objects here, and you can see this so much images in this area because it's very challenge area, huge block here, and so on and so on. Here areas, this area, it looks more clean because this is very close to the harbor, so that's why the visibility was very good when we captured this area. One of the other goals for this mission is to generate the digital elevation model. Of course, for many reasons, because one of other studies to the site is not study only the object, but also study the island of Faros. Uh, we are planning also to create digital surface model for this subject. However, this is, as you can see, the start depths for the site on the ground based on the zero level or the ground level is 0.24. So this is a red area. This one underwater 0.24 meter, and the maximum area on the site, which is the blue area, is is around 10 meter underwater. So first of all, after we do the georeference, we do a comparison between the GIS map done in the 19s and our new georeference also recified image, and we find there are shifted 30 centimeter because what done in the 19s, we know that, or the topographer knows that we have up to 1 meter error in the X and Y and Z position. So we had also to remap the whole site based on the photogrammetry. As you can see, of course, one of the benefits of creating also recified image, we can make the 2D drawing very easily. And this is extremely high resolution image, and this is an ortho-recified image. So ortho-recified image is a measurable image. We can make the 2D drawing based on this one. It's undistorted image. So, however, one of the most interesting areas that when we capture this area has the corniche of the gate of the lighthouse. This is the corniche. But in 2014, we find some blocks around the corniche, and in 2016, we didn't find the blocks around the corniche, and we did some deviation analysis to know what is going on, and we know that the sand level in 2 years getting high around 60 centimeter. So this means that maybe in the future we will do underwater excavation to discover more blocks. However, we did remapping to the whole site, as you can see here, and we discovered that there are around 7,000 blocks recorded. This is a huge discovery because, as I mentioned, in the 19s we only know 3,500 blocks. Now we know over between like I guess around 7,000 ton of addressed block, like 7,000 block now underwater. So this is something changed the whole history of the lighthouse. So, however, the processing was extremely challengeable for us because we are dealing with a huge amount of images, and the software sometimes it's very tricky. You need a specific machines. And in 2014, especially when we started the project in 2012, the machines, the computers configuration wasn't even in the industry wasn't that much good. So we worked in what we had. So I remember in 2013 there were a Python script provided by the EGI soft MetaShape support team to do something called divide by blocks. Like the processing will automatically divide area by area, which will accelerate the process. Luckily, in 2000, I guess 22, 21, they integrate a new feature inside MetaShape that you can divide the processing into blocks, as you can see. And this is what I redone actually a year ago. I start to redo the whole processing because now we have a better machine. Well, I will show you also in the application MetaShape how it's been done. So for example, this 23,000 image, and we use the new feature which divide by blocks here. As you can see, the software divide each area. This means that there are no more consume of the RAM, no more consume of the graphic card, extremely fast process. And like if I do the whole 23,000 image and only align with my incredible machine I have right now, it might take between only the align might take 1-2 days processing, but by If I go to the mesh, it might take, like if I do it in medium or high, it might take few days to finish the process. Maybe I will end up with a crash, not enough memory or whatever it might be happen. So that's why this feature is incredibly amazing. The whole 23,000 image just finished in a few hours, I guess. As you can see also here in this area, as you can see, oops, incredible high detail area. So anyway, one of other thing we can produce to the audience is to make a virtual tour. Like here, as you can see from this video, before I start this video, in real life, as I mentioned, it's impossible to see all of these blocks as one piece. For example, this is one of the coronation of the lighthouse. In reality, I can see only between 20-25 from these blocks, percent from these blocks. But once we have the whole 3D model, we can put it in any other software to do animations, annotations, create our underwater environment to make it more visible to the audience and to see more the lighthouse in one image, as you can see here. In the video, I put a diver here to see how enormous the blocks looks like. So basically, the process is not only take the photogrammetry, because we end up with millions, hundreds of millions of polygons. So we had to do post-processing like clean up the mesh, optimization, retopology, baking the texture, make UDIMS techniques like divide the texture to hundreds of texture to get the maximum texture quality. So I spend not so a long time, because I'm doing that from over 10 years, but it has to be done. You cannot put 100 million polygon in a 3D Studio Max or Blender or any other softwares and do this video. So, however, this video is basically it's on YouTube. It's 5-minute video, but now I shorten in 1 minute. I did this video in 2015, and to render the 5 minutes took for me 1 month, 24 hours every day to create this 5 minutes. In 2022 or 21, I guess, or 23, sorry, in 2023, I put the same site inside Unreal Engine, game engine software, and I created my underwater environment and start to do only 1 minute and see how it took. Actually, I put the whole thing and I make 1 minute in only a few seconds, because it's Unreal Engine in the real-time rendering. And as you can see, this is made inside Unreal Engine. Much more higher quality. I tried in Unreal Engine to simulate exactly the site, how it looks like in real life. So I put God rays, fishes around, caustics effect. And can you imagine the 5 minute in 2015 took for me 1 month? In Unreal Engine, this kind of incredible quality took only just a few seconds to render the whole camera pass, which really was a game change for us. So, however, I will jump because I don't want to take so much time. In 2023, late in June, I was in Naples actually present a virtual reality tour for the site. I was present a paper in the digital technology conference about how we can experience the underwater site in VR. So I made a very basics to be for the audience to see how it looks like underwater, to have the feeling of how enormous the site looks like. Of course, I made the visibility very good. So it's totally different thing when you wear the VR. Really, when you wear the VR headset for the underwater side, it's unbelievable. It's totally different experience for underwater. However, this is actually how it looks like in Unreal Engine. How I'm just like made the underwater effects and this kind of one of very interesting thing. Like I will just like go back here because this is very important thing. Uh, if you remember the first, second, or third slide when I said in the 19th Centre d'Etudes Alexandrie with the Ministry of Egyptian Antiquities left some underwater blocks from underwater and put it in the open museum. Those blocks are belong to the ancient lighthouse in specific locations. So we go to the site. This was, I guess, in 2018 or 17, something like that. We did a whole photogrammetric model to the whole blocks made lifted from in the 19th. So we made a full photogrammetric model, and actually we start to think about reboot virtually the whole models or the whole statues, obelisk, whatever we find underwater to the place. Sorry. And this is what it looks like in Unreal Engine. So, for example, the colossal statue of Isis, or maybe Arsene Way, we after we made the photogrammetry for it, we decide to put it back where it is. So, as you can see, the Isis statue was divided in 3 pieces. So, inside Unreal, we I try to know where exactly it was before from the old GIS data, and and put the 3D model is not only photogrammetry but also it's converted to game assets. So it looks like very high quality model, but it just actually it's 50 or 100,000 polygon, maybe less. And it's included different maps like normal map, displacement map, and others map. So because if I put these millions of polygons in Unreal Engine, like the software will be extremely heavy. As you can see now, I can move freely without any problem. But actually, I'm not concerned about this right now because Unreal Engine integrated a new technology called nanite technology, which I can put millions of polygons as I want. I will not care about number of polygons. So anyway, how we capture underwater in the site, in the underwater site, our site is a lighthouse. We use only camera. This diver was in oblique image, or at least 30-degree angle to capture the site of the blocks, and he keep back and forth. We didn't use any external light, but a lot of archaeologists actually put in their camera a strobe light here to get more visibility, especially if they are dive more than 15 meters under the water. So to put light in the camera, this means that the post-processing and remove the color filter will be possible. If you didn't use the light, it will be difficult or nearly impossible to remove the filter color for the image. So some of them, most of them actually use strobe light attached to the camera. As you can see here, this is different of strobe light. Some of them not using professional camera but use a GoPro camera with ultra fisheye or wide angle camera attached with strobe light, and the result is really, really incredible. Some of them I use actually this kind of scooter, underwater scooter, and attach the camera on the scooter and just like make adjust the time lapse feature in the camera, either way in the professional camera or the GoPro, and for each 1 second the camera automatically captures the photo, so I don't have every time to press click 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 on the camera, which might be very confusing for non-professional photographer underwater or diver. So just adjust the time lapse feature. So this is kind of tips. What kind of lens I'm going to use underwater. So it's back to you. For our case underwater, because we are archaeologists, we are aiming to get the maximum details as possible. So we use 24 millimeter. We are not caring about the amount of photos, how long it take, because this is endless project. Uh, so we are not restricted with time for anything. Uh, you can do it faster by increase the camera lens, make a fisheye or ultra wide angle, uh, whatever. If you are concerned or you are not a pro diver, you can adjust as a time lapse feature in the camera. Uh, so for each 1 second, 2 seconds, the camera automatically captures a photo. But you have to make sure also you are moving underwater or dive very, very slow to make sure there are enough overlapping image. If you are so much aware and this going to be one time dive and you are so much concerned, you can do videogrammetry. So just do video underwater, and I will show you in the software how we extract the frame, the video frame. We had a lot of experiment in the site compare between photogrammetry and videogrammetry. We got nearly the same result, very close same result. Video is really much faster, really much easier, uh, but not professional. Uh, you know, if you are, especially if you are archaeologists, it's just a tricky because we are not got the metadata from video frame. Like ISO, shutter speed, and this. So the calibration in the software done automatically, not automatically by guessing. So which I will show it to you. One other amazing thing, if you are going to scan or do photogrammetry for shipwrecks, shipwrecks have some very narrow rooms. So you can do it either way. You can merge between normal camera lens and videogrammetry, ultra wide angle lens, and also you can do panorama capturing or panorama video, like videogrammetry panorama. I have no idea, I'm just like guessing the name. But we had so much experience also about panorama capturing. The result was really outstanding, but it needs some specific setting. I will show it to you to do in Metashape before to do any panorama capturing. You have to very concerned about the details coming from the panorama. Uh, uh, and the calibration of the camera, very challenge for you. But it worked. It worked quite well, very well. But just for a narrow space, you can only use a panorama and don't count on panorama for the whole thing. Just for narrow spaces area. Well, there are show it to you different techniques for virtual anastomosis before I show you the Metashape, the Aegisoft Metashape. For example, the colossal statue of Isis, which is 12-meter high. In 2014, we decided to make a photogrammetry for each piece individually. The Isis statue was underwater, divided in three blocks. The upper body and the lower body, which lifted by Egyptian Navy in 1962, and the crown of the Isis lifted by Professor Johnny Van Brain in the 1994. To do photogrammetry was a challenge because the crown is located in the Roman Theatre Museum, Open Court Museum, and the other two pieces located in Maritime Museum, different place. So it was impossible to take the three pieces, bring the equipment, and put it all together. Will consume a lot of time and money. So we decided to do that virtually. So, however, we did photogrammetry for each pieces. We have a crank to flip the object upside down, and I did photogrammetry. We tried to merge the three area together, which really fit perfectly. Don't care about the colors because it's capturing in different time condition. Isabel Harry start to based on the photogrammetric model to do some sort of reconstruction from 2D drawing, 2D reconstruction for how the whole Isis statue looks like. In 2020, I guess, or 21, the Ministry of Egyptian Antiquities and some architect company contact with CEO Alex and with me because they would like to reopen the Greek and Roman Museum, and they would like to get some information, the 3D models, to build the methodology on how they will erect it inside the museum, and also to rebuild the missing piece. So anyway, I gave them the information. One of the greatest information coming from photogrammetry is a cubic meter. So they can decide what kind of equipment they will bring to lift the object. One of the most incredible results that you can do inside MeshLab software. There are great features to see more details and remove the texture color. As you probably know, granite texture is made from very intense stone, and it's very difficult in real life to see some details. But by use, remove the granite texture, apply some filter, you can see some details on the statue. It's really difficult especially for the research and studies, to see this kind of details, like the dress, the necklace on her neck, and a couple of other features. Difficult to see it in real life. So anyway, I'm just like make a very very quick video on how this going to looks like, the anastomosis of the three pieces compared to human level, to see how huge it is. And now, as you can see, if you come, I hope one day in Egypt to visit Alexandria, in the Greek and Roman Museum, you will, in the open court, you will see the statues. And just remember me, I'm the one who did the photogrammetry. So anyway, this is some of the images in the 19th, how the divers was lifting. Sorry, I have to back to. Oops, sorry. Yep, here. I don't know why it's keep very fast, but just 1 second. Okay, here's the thing. So these are some image on how the diver was lifting the statues underwater. Some of the statues we did photogrammetry from some of the models underwater. The challenge, the statues actually and the blocks are huge, massive. We are one of other goal of the site is to rebuild the lighthouse based on the photogrammetric models we create. Like we will do photogrammetry for each piece individually from upside down and recreate the lighthouse based on actual data, like puzzle, like we are doing Lego. So we underwater to flip object upside down, it was a challenge, but we have a balloon underwater to lift it and flip upside down, as you can see from this image. Those are some images how in the 19th they left the statue. We have also Ptolemy II statue discovered, and these are lifted on the 19th here. The statue now erected in front of Alexandria Library. And in 2001, the hand of the Ptolemy statue discovered and erected. So, however, we made also photogrammetry for the statue and also for Ptolemy II, as you can see here. This one. I can quickly go for another anastomosis thing, which not underwater, but it's very interesting project. Also, I was part of it in 2018 in Tanis in Middle Egypt. So it's a very big temple called San al-Hagar in Tanis. And I work at the Ministry of Egyptian Antiquities. So the people in charge in Cairo asked me to do a photogrammetric model to Ramesses II statue, which was, as you can see from this model, is divided into 5 pieces, and do anastomosis and give the data to the restoration team to because they were actually decided to rebuild the statue and put it inside Grand Egyptian Museum, which, by the way, opened 12 days ago. And if you go there in the museum, you will find the Ramesses statue there, and they do the whole restoration. So, however, I'm just like do photogrammetry for each piece individually, do the anastomosis, try to rebuild on the site how it looks like, as you can see. And now, after I made the photogrammetry, now if you go to the Grand Egyptian Museum, you will see Ramesses statue erected. And I didn't do the restoration for the missing piece, but was part of the restoration team. Muhammad Saidi is this guy. He's the one who contacted me to do the photogrammetry and the anastomosis. So this is also a quick video how just like, you know. The statue on Sketchfab, actually, I put it on my page on Sketchfab if you would like to see it. So this is a view inside Sketchfab, how it looks like. So it was a great way also to use Sketchfab animation, integrate animation on a Sketchfab to see how the pieces are so much attached together. So well, I have another example. I'm not sure if you going to, it's not an underwater, but maybe since you are doing cultural heritage, this might be very interesting for you, is combined between 3 different technology, photogrammetry and unroll, cylinder shape, and virtual RTI, which was very, very interesting topic. I put it on my PhD thesis as well, which is part of the funeral base discovered in Aswan in the south, Upper Egypt. We know that there are inscriptions on it, but the inscriptions is nearly impossible to read. First of all, because of the granite, and this is thousands of years ago model, so it's totally eroded, and we only can see some letters when the sun in a specific time in a day hit the object. So, however, I decided to make a photogrammetry to see what's going on when the RTI idea come to me. And since it is a cylinder shape inside Mesh Labs, there are an amazing feature for unrolling cylinder shape for 3D. This feature also in beta shape, but for 2D. You can create digital elevation model and also receive unrolling, but you cannot export it as a 3D. Anyway, in Mesh Labs, it has this feature and it's worked perfectly fine. So I unroll this shape, and I removed the filter colors, and we can see now the Latin inscription. However, the one in your left is how it looks like in real life. The one in the middle is when I move the light in Mesh Lab, and one on the left is after I remove the texture and apply some filter in Mesh Lab to see the light. So, however, I also decide to do RTI and see what's going on, how it will looks like, and this is actually the result, and it's really, really incredible to able to read the whole thing. As you can see from the original one, if you visit the site and see this base, you will never think there are an inscription on it. But actually there are some inscription on it, as you can see. 7 Latin line. So by keep moving the light, of course, you can see more letters. So anyway, so this is all about the presentation. you can also ask questions, but before that, I'm going to show you the underwater site and some tricks on the software. So as you can see, this is the site, which on Metashape, in Aegisoft Metashape. This is what it captured in 2014. So this was a big challenge because as you can see here, we have 25,000 image 800. The only ones aligned is 22,800. It doesn't matter because we had a huge amount of images. Those images are not add any extra stuff, extra area or anything. So that's why we didn't care that much. We process the whole thing at once by using feature, which is if you go to the workflow and build the model here, you will find a new option called blocks. So you will choose, of course, the depth map method, which is very faster than using the dense point cloud. You choose quality and, of course, the blocks area, which is the most important part. So you will tell the software split the model by blocks. First of all, to be able to adjust or enable this feature, you have to make sure the model at least is both either way georeference or scaled, because you need to know the scale of this boundary box. So let's, for example, we know this one. I will take the scale of this site here from this point to that point, for example, and this is 66 meter. For example, just like estimate. So I will go to build, split in the blocks. I will imagine this is not a coordinate system, because if it's a coordinate, I have to put some coordinate. But either way, if it's a georeference or not, the block size is the most important thing. So how long the block you would like to do. So I know that this is 66 meter. So I need the blocks to be every 5 meters. So the software will, every 5 meter will do the processing, and so on and so on and so on, every 5 meter. Every 2 meter, every 3 meter. This will make the process extremely fast because the software will only build the depth map for this area, for example. Then the software will go to the other area. This will be really incredible fast feature. You will end up with a result called the block model, which is this one. Block model is an LOD file. So I made it in the lowest quality here. As you can see on the presentation, I'm not going to open it because this might be very heavy, but it will end up looks like that. Blocks, 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 blocks like that. And this is actually, if you keep zoom in, you will see details. If you zoom out, you will get a lowest LOT, so it will looks like crunchy and like 10,000 polygon model. If you zoom in, it will turn out to millions of polygons. But the problem is I needed to export it as a one geometry. You cannot export it as a one geometry. So what you are going to do after you do the blocks, you will select all the blocks here and right click and merge. Once you merge it, you will get another model here. This is I decimated, actually. This was like around 50 or 60 million polygon. But however, you will get this one model, as you can see here. So after that, before I build the model, I put marker because as you can see here, the site is already georeference. Let's see how the georeference looks like. So if I'm just like filter photos by marker and see some marker here, I hope not here. Yep, here. So this is how the marker looks like. So the diver tell me exactly where's the point taken. Maybe here, maybe I don't know. So yes, here in the middle. So he tell me in the middle. So we have a diameter of error here in the middle, which was fine for us actually. We got, for example, we got a final error is 0.6 meter, half a centimeter, which for underwater photogrammetry is totally acceptable. It's totally incredible, amazing. We can see some of, as you can see here, this is an obelisk, part of obelisk here. We can see the two-door lintel of the ancient lighthouse. This is actually, you know, Isis statue. This is actually the base of the statue here. We have the full photogrammetry for this one, so we don't care about the side of it. So this is actually the door lintel. A part of the Bavarian column here, and so on. So this is only 2014. So how we merge everything together, as you can see, for each season I work individually. This was in 2015, the second season of the year, 2016, 14, and so on and so on. And once you make the georeference, if I just press on this button, which is align the georeference chunk or folder, just 1 second. It's going to take a little bit sometimes, but as you can see here, this is how I will just disable the marker, and I will unhide the boundary box where it's a boundary region here to this site. And as you can see now, we have the whole sites in one area underwater. So in real life, you will never ever see anything. Let's see, for example, the dimension of this one. This is a georeference, so we know the accurate. So this one is 5.37 meter, which is huge. In real life, you only see like just this area, you know. Just if I go to draw polygon, you will just like see only this area in real life. And by the way, also in Metashape, you can do the 2D drawing in Metashape. So you can just use this drawing polygon, and you can do the whole 2D drawing in Metashape, export the shape file in AutoCAD or Illustrator or whatever software you want to do. And the exportation will be in geolocation, by the way. So it will be incredible. So anyway, this is how it looks like now after we capture over 143,000 image, starting 2014, the actual mission, till 2024. I still have another 30,000 image. I'm going to work on it maybe in a couple of weeks. So anyway, this is for the site. And what about video? So I made a very interesting result to make a compare of video. So in 2000, let's see here, files, and we have here like as you can see, this happened like around 6 years ago when I decided, okay, when I asked Diver, let's do a comparison for fun to see videogrammetry, how the result will be. And after we finish videogrammetry, do photogrammetry to the same area and make a comparison between the result. And as you can see, just like very close to the object, he moved very slow underwater. He keep go back and forth. And after that, I'm not going to show you the whole video, but after that, now I have the video in MP4. You have two ways to extract the frames. First of all, you can use Metashape. If I just build a new chunk here and import video here, I can just drag and drop here, which is sometimes it's not working, but let's import the video here. So once I import the video, as you can see, as an MP4, I will have the whole video. First of all, the software should export the camera sequence. This video we capture is 30 frames per second. So for each second, the software will extract 30 images for each second. This small area is 6 minutes. This means that for only small area, I will end up with over 10,000 images. I don't want to have it. I just want to tell software for each second to extract a specific amount of image, not the whole 30 image. In Metashape, there are no feature like that. but there are a feature control with the overlap, which on the frame step. So first of all, you will decide where exactly the extracted image will be. This is QB Kaibei, and this is going to be in this folder, and I can put the file name here, just QB whatever number. So here is the thing. So there are, if I open this option, I will find small, medium, and large. Small meaning that for each second there are 30 images. The software will not extract the 30 image, but will extract 7% from each second. So 7%, that's small, means small overlap. Like, let's say in other words, in each second there are 30 images, but the software will minimize to 90% from each image sequence. 7%. Medium is, I guess, 12%, 10%, something like that. Large is 17%, something, I don't remember the number, but you can see it in the manual. Or you can do it custom. I need for each second, there are 30 images, but to minimize it to 50% image. So this means that will end up for each second, not 30 images, but might be 3 images for each second. So this will make each second have 3 images, 6 minutes. You can do the numbers and you will end up with a few hundred for the area. So you have to tell the software, okay, start from the first frame of the video, then you will slice it down to the last frame and tell the software end at the current position. You can make only photogrammetry for only 3 minutes, 1 minute, few seconds to do the test and so on. So this is the first method. You don't have a control with the number of image sequence, but you have a control with the overlapping image on the frame step. But if I would like to have the number, like if I want exactly number from each second, what should I do? So I have to use another software for it. So, but anyway, let's show you the result I made, and this is only the alignment from the video. As you can see, the alignment went perfectly fine here without any problems. The only one problem as archaeologists, you got the NC for each frame, which means not calibrated. Because if I go here and open in the details area and I open this, I'm not going to find any information about the ISO, shutter speed, the focal length, because it's an image sequence. And if I go to the calibration here, camera calibration, so of course I will find this I error. I have no information for the calibration. So what is going on? The software guessing it's captured by 50 millimeter lens and do the calibration based on this. As archaeologists or engineering, this is not like so much accurate, but the development of the technology make it actually happen. And we got incredible result. Incredible, really, compared to the photogrammetry and the fast. Photogrammetry, for this one, you have to do the blend, grade, and so on. This can take like sometimes. Videogrammetry, just 6 minutes, you capture big area. Like this is a giant area. This is not a small area. You might see a small. This is a small area in real life in 3D, but in real life, this is a huge area. Just 6 minutes. So yeah, videogrammetry worked pretty well, pretty fast, very accurate, but no calibration information. So you have to decide what you are going to do for your project. So anyway, let's back again to how to extract video by numbers for each second. So how are we going to do that? I will open Photoshop. I will take the video, import it in Photoshop. So now I have the video in Photoshop here, as you can see. After I import the video, actually I can do color collection, color balance, everything in Photoshop to remove all of this color, but I'm not going to do that right now. Anyway, to render the sequence, I will go to File, Export, Render Video here. And I will change Adobe Media Encoder to Photoshop Image Sequence. I will select the folder. It will be this folder, for example. And here is the thing, frame rate. I capture the video for each second, 30 image will export it for each second. This means that for each minute, you have to do the number, which will end up with 10,901 image for the whole 6 minutes. So if I would like to have more control, I will go here to tell the software, make it 10 image per second, or 12, or whatever the number, or do it custom. As you can see, I do it always custom, and I say the software, okay, I need 5, 4, whatever number will be, you have to do test. Usually I do test for the first 5 seconds, 1 second, to see the overlapping, how much it will work. So I do it for a few seconds at the beginning, then once I know that the overlapping is work quite well, then I do the whole thing. So when I tell the software, make 3 image per second, export it, it will end up, with few hundred image, not 10,000 image. So, and this is exactly what I did with this example. I make it, I guess, 3 image per second, so I ended up with 1,300 for this big area. So to do that by overlap, you can do it in Metashape. If you would like to have more control, do it in Photoshop. So you can do your decision. So this is how to do videogrammetry. What about panorama videogrammetry? If I would like, for example, if I have a shipwreck, and if I have in this shipwreck, I have a very narrow room, I want to merge the outside with the inside, and I only have a camera 24 or 18 millimeter. This is going to be extremely difficult. So you need more wider angle. So first of all, you can change the lenses. You can do different dives, or you can have 2 cameras underwater, whatever you decide to do. But anyway, you can do panorama videogrammetry. I don't have any example underwater, but I have a videogrammetry for a site called discovered a couple of years ago, called Golden City in Luxor. One of my friends work as a ministry. He captured a panorama, as you can see here, and he was walking. Actually, he didn't do that for photogrammetry. He just was doing that for fun. He was just like moving around for fun. And when I saw the video, this happened many years ago, I said, oh my God, I can't do photogrammetry with this panel. And I do the same trick. I took this video, I put it inside Photoshop, export 3 couple of images per second. As you can see here, he was keep moving very fast. Like, this is only 4-minute video. And this is only 1K quality image. Like, when I export it, it's just 1K. Like, I said it will never be happen. Like, I will never be able to do that. But actually, I export the frames, and let me show you, as you can see here. This is the frames actually exported. As you can see, he is still there. You can actually, you can do a very nice trick about this guy here. So how to remove this guy from Metashape if I would like to import it in Metashape. So to do that, you will just like make a new layer, make it black. I will just make it a black layer, and you can generate a mask. So where is this guy? Here is a guy. Just do it. So in the whole frame, the guy in the same destination here. You can just like put here and make it white and export it as an image in PNG called mask. Name it as a mask. That's it. I'll make it PNG. and save it. And inside meta shape, actually, you can import and mask. Like you can import this only one image, and it will automatically apply to the whole images automatically. Anyway, in our case, I didn't do that because the software luckily didn't detect any feature point because the guy was moving, so I didn't bother myself to do it. Anyway, this is actually how it looks like. Again, he didn't intend to do that for photogrammetry. He was actually walking around. So the thing is here, how to process panorama image in meta shape. So there are a few things you have to keep it in mind. If I put the images and make a line, will never be work. But I have to tell the software this is a panorama image. So to do that, once I import, actually let's import some image here. Let's import a full image. So I have here 5 images. Here, as you can see, it's not yet aligned in A and not calibrated. But before I do the process, I have to go to Tools, Camera Calibration, and tell the software this is not a frame image. This is actually a spherical camera. This is a panorama. So again, if I'm going to use also the fish eye, the GoPro underwater, I have to tell the software this is a fish eye taken by GoPro fish eye camera frame. If I will do it with a professional camera, with a normal frame lens, 18 millimeter, 15 millimeter, whatever millimeter, I have to keep it as a frame as a default. If I will use it as a GoPro, I have to change it to fish eye. If I will use a panorama image, I have to tell the software this is spherical. I have no idea about what a cylinder lens is. But anyway, in this case, I will use it to spherical, and rolling shutter compensation, I have to change it from disable to full, or, oh, sorry, not this one. I will keep it this one. Or, no, actually, I have to make it as a full. Or you can try with this. So anyway, what is rolling shutter? Basically, if the camera is keep moving, because you do videogrammetry and keep moving. So if you have the frame, keep moving and have this kind of shaking, this going to resolve the problem. So you can try it with disable or try to play around with these two options. So however, as you can see, when I make it as a frame, I have this kind of eye question mark. But when I change it to spherical, now it worked perfectly fine. I will press OK, and I will go to workflow, align, and I will make it as low as the same time. So anyway, well, I will keep everything as a default and see how. It's not a photogrammetry course, so I'm not going to explain. So it's going very fast. Now I have this in low align image, and if I bring the camera, as you can see here, this is how it looks like the alignment for 5 image. And it's aligned pretty well, like here, as you can see, this is how the guy moving. So the camera is not like rectangle, but looks like sphere here. So as you can see, he didn't do that for photogrammetry. He was just like moving around. I took the 1K video for fun and see what's going on, and it's working incredibly well. But you have to make sure that the calibration is changed to spherical camera. So yeah, so this is up to you. You can use panorama, you can use fish eye, you can use full frame camera underwater, you can do time lapse underwater, you can do videogrammetry, you can I'm just like, if you ask for my recommendation, I recommend to do either way, GoPro or professional camera, and use a strobe light. So this is my recommendation. In our case underwater, we didn't use a strobe light because, as I mentioned, we have plenty of time. We choose the best time, best day. If you dive very deep to do shipwreck, if you are doing interior, very dark rooms inside the shipwrecks, you need definitely an external light. So you need the strobe lights. One of other very interesting thing about ISIS, this is a virtual installation, but at the same time, I was in part of the project to do a full reconstruction of the statue based on this 2D drawing here. This one, just 1 second to be here, based on this 2D drawing inside ZBrush. As you can see, we did the photogrammetry for the statue here, and I made a reconstruction sculpting, for second. Where is the reconstruction? Yeah, as you can see, you probably know what is ZBrush, so it's just like sculpting software. But anyway, as you can see here, for the missing pieces, I just try to do fully reconstructions for the missing pieces. This is doesn't made by imagination, but we have a fully photogrammetric for so many different examples back to the same time in Ptolemy era for Arsen Way. So that's why we know exactly what we are going to do and sculpt. So this is not leg and just sculpt legs. We need examples. So that's why I have a lot of reference to know when I build, like, for example, I have a very interesting reference here. Let me, this one Cleopatra 7, actually, this is actually Way model in the Louvre. I was in the Louvre a few months ago and I was walking around and I captured it. So I know how the legs going to be looks like, how the angle, at the same time, the same era. So the hand, how the hand looks like. So I took it as a reference, for me to rebuild the whole model. And in ZBrush, of course, you can. Anyway, this is not a ZBrush course, but you can just like do sculpting and the details. So yeah, I'm going to stop sharing. Oops. Okay, this is a course. This is, oh, sorry, this took so long time. I'm sorry for that.
No, that was so impressive. Also to see all the campaigns together, all the anastylosis of the statues was really, really impressive. And I'm so glad that they were able to reconstruct the actual statues from your photogrammetric anastylosis, which I'm sure helped a lot for the people above to see the whole thing and then decide to reconstruct them. Also about the all the underwater photogrammetry, it's incredible the scale of the ashlars, of the huge stones that are underwater. You cannot even imagine it until you put there the diver, the small diver, and then you can see the real scale of it because, well, it's just incredible. And I'm so glad that you did all of this work and that you're continuing doing it. And I want to see those new 30,000 photos from
Yes,
2025.
unfortunately, we have a very challenge, Nestor, right now because military, the Egyptian military, built a few years, not a few years, but last year they finished build a block wall in
Okay.
front of the site, and this is make the site not auto cleaning, and
Ah,
this is makes
yep.
our work extremely difficult. In bad days or even good days, the visibility is half meter. Now in good days, the visibility is 30 centimeter. So 30,000 image captures this year is very small area, just a very small
That's
area, and it's just
crazy.
like
Yeah.
crazy. We cannot use a strobe light. We cannot use even any kind of equipment. You have to be extremely close to the site. So
Yep.
they were. I totally understand they do that to protect it from tsunami or and protect the castle of Qaitbay from things
Hmm.
happen. But this is makes the whole
Yeah, but
site
in a
not auto
way,
cleaning.
yes,
Yeah.
yes, you're damaging the site, and even that is really interesting because when you showed the photogrammetry from a year and then some years later, all the sand is up on top, and you cannot even see the blocks that you saw a year before. So it's really, really important to have that in mind to see how a photogrammetric model captures a moment in time also, because the site can change easily.
Exactly, exactly. Yes, yes,
Really,
yes.
really important. And it would be interesting also to excavate all of that. But I guess
Yeah,
that it's a huge
actually,
site.
a few months ago, my colleagues was diving underwater, and they
Hmm.
discovered, actually, because there were enormous amount of blocks underwater. They found, actually, under these blocks, layer of
Okay.
blocks, there are another layer of blocks.
Yeah,
So they are on each other's.
that's it.
So we have a huge amount now of plots. We will never know
Oh
about
my
that
God.
without photogrammetry, you know.
Yeah,
And we
yeah.
are archaeologists, so we know what we are doing. When you do photogrammetry, you know exactly what you are working on, what kind of information you are seeking for.
Hmm.
For me, if I'm just like, as a hobbyist or do these things, I will show it to you. Oh, see, I did photogrammetry, looks very great, but there are so many information you can extract it.
Yep.
uh,
No, it's
my
really,
my
really.
colleagues my colleagues French colleagues, they never catch these, but because I'm the one who does the processing, I catch all of these small
Yep.
details and tell them these things and that thing. So it's great to be.
Yeah.
Yeah.
And are there any plans to do a reconstruction of
Oh,
the whole structure
we
from the
actually,
blocks?
yeah, actually, we first of all, we rebuilt the whole gate.
Right.
We made the whole statues. We are in a project funded by the So System Foundation
Hmm.
in Paris. They just sponsor this project to do first HBIM,
Hmm.
Building Information Modeling,
Yep.
to the whole site, and to rebuild the whole lighthouse based on the information gathered by us.
Hmm.
So this is going to be the last year of this project. It started 2 years ago, and we have a very interesting result. Yeah, yeah.
It's
It's
would be great
the
to
main
see that.
yeah, the main aim is to be in public
Hmm.
visualization, and this kind of things. We are like the good rendering and visualization. We are not focusing on it right now. We
Yep.
just focus on the main studies. So the
Of
HBIM will
course.
be looks like grayish and this kind, but have a huge amount of informations.
And also about the VR experience, is that released to the public, or are you planning to do
No, no,
so?
I was just like doing this for the conference. I
Okay,
just
okay.
do it by myself. Unfortunately, I cannot even release any of things.
Yeah,
But
I get
the
that.
whole 5 minute video on YouTube, I can share
Hmm.
the link. I don't know if you know about this, but let me share with you in the chat box right now
Yeah.
to see the whole 5 minute how the site looks like.
Yep.
Okay, I will put it on the chat box for everyone. Here. Okay, so
Yeah.
this is the
There you go.
YouTube. Yeah,
Hmm.
I will put also my page on Academia. I published over 11 paper for the site
Hmm.
in very big international conferences. So you can, if any of you would like to know what in details, like in small details, what we are doing. So this is my Academia page. So
Hmm.
if everyone would like to no, there are so many articles I made for the site. So
Yeah. So really interesting work. Thank you so much. I don't know if you guys have any other questions, something you want to wrap. Go ahead.
Yes, first of all, Mohammed, really impressive to watch or to see what you have done
thanks, Ralph.
from
Thank you.
2012 on. It's really impressive, and I can totally relate to the computer power that you had in 2012 and now. And I mean, Roshan and me, we started in 2005,
In
and we were creating 3D models. So it's a
yeah,
complete different ball game
if you
that
see
time.
my articles, the first article I made in 2015, this was integrated the computer configuration I used in 2012, which was my personal computer was 16 giga of RAM and the GPU is
Hmm.
just 1 giga. So it was
Yeah.
my personal. I spent like years have this money to buy it by myself. So in 2012, we wasn't have this capability, computers capability.
Mhm.
I have a question regarding, I mean, we are starting now since a while experimenting with Gaussian splitting. I know you've
Yes.
probably heard about it.
Oh, of course, yeah.
So are you planning to take your images and run it this way? I mean, because
Well,
it is a complete different level of 3D experience,
no,
and the
no, no. Just
quality you get.
I have to. The quality is great in terms of visualizations. We are archaeologists, so we need to have a mesh. We need to cut sections, elevations. Cajun splatter,
Yes,
I hope.
it's just a
So
visual, yes,
visualizations, point cloud, splatter of point, but it's
but it's good for the public.
incredible good for public,
Yeah.
virtual
Yes,
reality, augmented reality, mobile applications. Like, for example, if I have these sites with millions of polygons, for example, and if I do the game assets concept, like do baking, geodems, create normals map, and I would like to do it as a mobile application, the texture also still the texture will be very low quality. But in the other hand, we can use Cajun splatter. I hope I spell this name is better. Cajun splatter.
Gaussian, yeah.
Gaussian,
Gaussian.
yes, Gaussian splatter. You can actually put Gaussian splatter inside Unreal Engine as a point cloud. It will be incredible level of details, incredible
Yeah.
texture, incredibly fast. In this way, you
Yes,
can
yes.
use
Yeah, it would
Gaussian
be a great
splatter.
example to test the
I'm actually
capabilities of the technology.
I was a couple of days ago was reading about some people do a game assets ran in mobile phone, use Cajun splatter and put some
Hmm.
avatar
Yeah.
walking around, and just when I saw it, just the idea pop up on my mind. Oh my god, I'm going to do that in underwater side definitely, and this will be incredible for underwater. This
Yep.
literally going to be incredible for underwater, because as I mentioned, the VR I made 2 years ago is a conference. Still, the quality it's great and unbelievable in virtual reality, but
Hmm.
still, the quality of the picture is very low, geometry. But Gaussian splatter might be a
And
game changing. Yeah.
you were talking about processing and the blocks and dividing the workload. So ourselves, we are working with very high quality, powerful machines, and so can you share your current specs, your PC, what you're
Oh
using?
yes,
So.
I have my PC which I'm present on it. This is 128 gig of RAM and the
Hmm.
GPU is 4090.
Hmm.
And of course the Intel is i9. So I don't know this is a high end, but still this is
Oh
do the
no,
job.
it's really, really high end.
Yeah, yeah,
We
yeah.
may have something bigger, but more powerful. But no, 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 absolutely, this is crazy, crazy powerful. So yeah, I was just thinking if it would make a difference to process everything together, not different chunks, but everything in a single chunk, even
This is
though it can take a few days.
no, no, no. Well, I'm totally agree with you. That's why actually I'm redone what I showed to you for the underwater times. This is actually work redone 2 years ago.
Yep. Hmm.
So I put the 23,000 images, one chunk to merging. But the site is really, really challengeable because sometimes not everything
Yeah,
work
of course.
quite well. No, the software, unfortunately, the software, if you put a huge amount of image at once, eventually after one day, if it took 1 2 days, it will not work probably.
Hmm.
The result will be totally might be weird in some places.
Yeah.
So anyway, long story short, the divided by blocks is really incredible techniques to
Hmm.
prevent from this to be happen.
Yeah, I was just thinking
I'm,
about
I'm,
just.
I'm sorry, I'm sorry to
Yep.
interrupt, but I have to go now.
Uh,
Oh
Um,
yeah, no worries,
I
Ralph.
have to switch off. Thank you again, Mohammed, and
Thank you, Ralph.
really great work. I really
Yeah,
enjoyed
thank
the
you, thank you,
presentation.
thank you very much. Hope I can see you
And
again
bye,
very soon.
everyone. Bye, Nestor.
Bye,
Bye,
Ralph.
bye, Roshan.
Bye.
We
Bye,
catch you tomorrow, Roshan. Bye.
bye.
So what I was just thinking is doing the alignment just the alignment of all the 100,000 or whatever photos, just to try to have them all in the same spot, in the same chunk, and then dividing the chunk into other chunks to do the meshing. But trying to do the alignment in the same one. I once did a project with nearly half of that, 50,000, and I aligned everything together, and then I process in several chunks.
Yes, yes. Well, this is a good point. It's going to be work if this mission is only in the same year. Our condition, I will speak in,
Yeah.
I will going to speak in our condition, my condition.
Yep.
Every season, the whole
Changes.
surface changes. The feature
Yeah.
point it
I
changes.
get that. I get
You
that.
know, the
Yep.
erosion it changes. It's impossible to align the whole 140,000 in
Yeah.
one.
Yeah. I get it. I get
You
it.
have we
No,
work at
it's
each season individually. Yes,
no,
yes.
but it's really impressive to see it all together, even though it's several chunks. It doesn't matter.
Yes.
So it's really, really impressive.
Yeah.
Yep.
Thank you. Thank you.
Anything else, Yara, Roshan?
I've got a couple of questions. Thank you again for this brilliant presentation. I really liked it. I've got a few questions, but you've spoken a lot and you're probably tired of speaking. So maybe
I'm
some
not.
rapid fire questions.
I am
Okay.
totally here. I'm very sorry because it's took more
Okay,
than
all
1
right.
hour.
Sorry, guys, I'm just holding you off here with my questions. So there are two groups of questions, one on data capture and one on the data processing side and output side.
Yes.
So on the data capture, did you find that the blocks moved after like 10 years, if any? And if the blocks moved, did that affect, the registration? And secondly, when you were doing data capture, what times of the day were you doing? Did you have like a 4-hour window or something to capture data? Or could you do longer? Because this is a real, it's real life conditions. And some days I want to know what kind of time window you had. And have you thought about maybe some new techniques in LiDAR, etc., new developments that can augment the kind of data that you already have? And so these are the data capture questions for now. Thank you.
Okay, so your first question about moving the blocks, that's amazing questions. Yes, we had some blocks when we go after 2 years, 3 years, some blocks are moving because of the waves underwater. So some of the blocks are just keep moving. What we are going to do with this case, nothing, because I'm working each season individually, and we know that in this season the blocks are not moving. So when we move to the second season, we know that these blocks are already moved. We keep it like as it is. We keep it at it is, and the alignment is not effect on the alignment because we use each season individually and merge by using the geolocation, the georeference. So we know that once it's merged together, and if there are overlapping area, we know that these blocks are shifted a little bit. So it's not harm us at all. It's not make a problem for us. So this is your first question. Your second questions about sorry.
How many times of data capture every day? Yeah.
The data acquisition and the sites, it's depend.
Yeah.
First of all, if we had a permission from the Ministry of Egyptian Antiquities for 2 months, we are not diving the whole 2 months. There are so many preparation because first of all, we are do photogrammetry for blocks individually. We have to flip it upside down, and another team do photogrammetry for the site. The team who do photogrammetry for the blocks, because the blocks are covered by eroded, there are a team do cleaning. Another team do build the grid and this can and put the ground control point. So this might take a few days, and after that we have to do the data acquisition. The data acquisition not every day because it's depend on the weather. So the mission choose specific days in a year, especially in winter, because it should be automatically clean the water. Not every day we can dive, unfortunately, because most of the days the wave is very strong, so we cannot do as a diver when he takes a photograph, he keep moving, the waves keep, pushing him away. So we are not doing this every day. How many hours we capture? Like we do like around between 2 and 4 dives. Each dive is 1 hour, 2 hours.
Okay,
So and it still depend on the
okay,
weather, the
all right.
condition.
Thank you. Yeah. Another question is on the data capture. Is this whole area a heritage site? And if it is, did they allow you to put markers on the stones? Because very often you're not allowed to touch anything on heritage sites. You cannot put markers, you cannot put control points
It's
and stuff like
considered to be a heritage site, but at the same time, this site is excavation site.
that. Okay. Yeah.
So we do excavations. We have a permissions, not me, but the French archaeologists have a permission to do
Okay.
excavations on the sites to do recording. There are not only people who do this diving, but also they dive with divers from the ministry to oversee, and it's collaborated project with them.
Okay. Great. Thank you. Okay. Let me just push on with my other questions now. This one is probably more difficult to answer. So let's say you have part of a door of a lintel or the entrance structure, and you saw where they fell. Okay, you found at least 3 or 4 pieces. Could you train some machine learning algorithms to kind of find out where you can find potential other ones, part of it?
Well,
Because
yeah. Continue, please.
it's
Continue.
yeah. So I'm just curious to know if you think this is something like this is possible, because you could look at simulations, how things fall underwater, and to find out where could be potential blocks of the door.
Well, actually, this is part of the project we are working
Okay.
on right
Right.
now with the soul foundations. But we know exactly where the lighthouse fallen. We
Okay.
find over 3,000 metal crown, like clamps. So for each block, there are should metal sketch for each block and another. We find where exactly over 3,000 metal clamps and distributed in a specific area. We know that this area is a lighthouse where exactly it's collapsed. As I mentioned at the beginning of the presentation, not all the blocks belong to the lighthouse, because in the Islamic time, they were at specific time. Sultan Qaitbay, I guess, I don't remember who is it, but he tried to prevent the Crusader from invade the country. So they took a lot of granite blocks to block the whole eastern harbor and sink it in this area,
Yeah.
in the eastern harbor area. So this makes our work so much challenge for us to know which
Okay.
where, this one is for the lighthouse, this one from the blocks he brought from whatever places. It's a challenge project, but for your questions, yes, we are working on this project.
Okay. Two more things. If you had to change something in this project, if you had to redo it from the beginning, what would you change in your data capture or your data processing?
Oh,
And yeah. Okay, go on. Thank you.
nothing. I already redo the work. Once I got the
Okay.
qualifications machine, and like before 2020, we didn't have enough machine to process this huge amount of data, so I had to do the process day by day, merge each day by marker. And this is leads that, because the overlap was low, this is leads that the overlapping has a problem in the z-axis. So that's why I redo the process in 2021 or 22, I guess, each season at once, to make sure the whole entire site in order. So,
Okay.
but in the
Okay.
processing, the data acquisition, we did it from the beginning, from 2012, with the high-end camera as possible. We are so much close to the object as much as possible. all the images captured in raw format. We didn't do videogrammetry. We didn't do any panorama grammetry. Videogrammetry and panorama was for experiment. So to see the result, not for documentations. So I don't think we are going to change anything.
Okay. One last thing. A few years ago, in my previous project we worked, there's a guy we worked from Canada. His name is, I think, Owen Murray.
I know
And
him. I know him personally. He's a
oh,
friend
you
of
know
mine.
him?
Oh, of course,
Okay,
yeah.
all right. So, he
So
also,
he's a
okay.
very
So,
close friend of mine. Yeah.
okay, all right, yeah. So we worked with him previously, I think, for some other projects in Egypt, in Luxor, and yeah.
Yeah. So
Oh,
what is your
yeah.
questions about him?
No, I just wanted to know if you know
Oh,
about him. Or if you
yeah.
know him.
Actually,
It's all the same circle of
yeah,
photogrammetry.
and we took the
Yeah.
same course in 2015 in Aix-Provence at the
Okay.
EGNS institutions.
Yeah.
Yeah, he's an amazing person, and I met him every year. There are here in America an annual meeting for Egyptology, the American Research Centers, and I usually meet
Yeah.
him there. Yeah.
He was also trying to unwrap the pillars. I remember he was also working on that. Yeah. Thank you. That's all from
Yeah,
me.
sure.
All right. So thank you all for being here. Thank you so much, Mohammed, for showing us this amazing project. I always wanted to see the lighthouse of Alexandria, so that is the closest thing we have for now. I hope you are able to do an astylosis of everything, and it would be incredible. But
I hope
such a great job. Congratulations, and keep up the good work, I
It's
guess.
amazing. Thank you so much, Mohammed, for your
Yara.
time. Thank
Thank
you.
you, Yara. Thank you.
I want to
All
do
right.
that, but first I need to learn how to dive.
Okay. Well, Yara,
Exactly.
I will surprise you with something. I'm actually the only one in the entire planet who do
Yeah.
underwater photogrammetry without know how to dive.
And it's not.
So no need to know.
I never been in this site.
I'm
That is
really
crazy.
thinking
That's
about
crazy.
doing that, but it's like always in my mind, like I don't know how to dive. So
all
no.
my articles, my master, my PhD is about underwater.
Nice.
And I know I never know. I don't know how to. I know how to swim. I'm from Alexandria, of course, but I never dived before. I never have this dive experience.
Oh, you have to learn now. You have to dive there.
I know, but
At some
this
point.
is crazy because every time I give a presentation, because this site was supported first from Honor Frost Foundation in England, and every year they come to Alexandria to see what's going on. I'm the one who presents the whole job, and Lucy Blue, she is the director now with this foundation, and she keeps saying, "Are you dive, Mohammed?" And I tell her, "No, I'm the only non-diver working underwater project in the whole world."
Oh god, yeah, you
But
must
you
be.
need to be the one who capturing that and then do the processing because it will be more like
Yeah.
I
Well,
believe-
actually, to do the capture and the processing is really important. But we are
I have a
on the
word
site.
for it.
Yeah, we are
I
on
have
the site. Sorry.
I have a word for it. It's called you eat your own dog food.
Yes.
When you that's how I call it. You start from the
You're
very
right,
beginning.
Roshan.
Exactly.
Full circle.
Exactly. But we are Yara, we are a good team. Like me, especially me and the diver are like one person. He does the thing is he in the same day he contact, like we have a very great communication together every day. Give me the data and he's live close to me, so I'm just go to him, he give me the hard drive, I do the processing very fast, I have the capability. Now I'm living in United States, I'm not in Egypt, so things are become very complicated now to send me the data, this huge amount of data. But we still do, now we know what we are doing. This might be complicated at the beginning, now it's not complicated because he know what he's doing, I know what I'm doing, so
All right.
Great, yeah.
Well, thank you again.
Thank you so
Thanks,
much.
Thank you so
everybody.
much.
Thank you.
thank you.
And hopefully
Yeah.
we'll hear more from you in the future. Maybe we can
Yeah.
even collaborate
hope
on
so.
a project. Yeah.
We will very soon. We will very soon
Yeah.
have a
Great.
potential meeting
That's
with
great.
her. Yeah.
Yeah.
All right.
Thank you.
See
Good
you.
to see
Thank you so
soon.
much. Bye
See you,
bye.
Mohammed.
Bye.
Ciao, ciao.
Bye.
Bye.
Bye.